Welcome, ladies and gentlemen, to some free response question review. In today's episode, we will be taking care of the 2005 Calculus BC question number 3 from the graphing calculator portion. This question also made a cameo appearance on the Calculus AB exam of the same year. The problem reads, a metal wire of length 8 centimeters is heated at one end. The table above gives selected values of the temperature T of x in degrees Celsius of the wire in x centimeters from the heated end. The function t is decreasing and twice differentiable. So it's a typical table problem. We should be able to handle most of the questions here. Part A says estimate t prime of 7, show the work that leads to the answer. That means we're going to squeeze t prime of 7 in between t of 8 minus t of 6 over 8 minus 6. Well, that's going to be 2, and then 55 minus 62 for the corresponding pieces, and that's going to be negative 7 over 2. And since they want me to indicate the units of measure, that would be in degrees Celsius per centimeter. Pretty simple way to get this problem started, so a little bit of integrated one slope in our house here. It says write an integral expression in terms of T of x for the average temperature of the wire. Estimate the average temperature of the wire using a trapezoidal sum with 4 subintervals indicated by the data in the table and indicate units of measure. Okay. The most important word in this question is the word average. When I hear the word average, I should think about 1 over b minus a. So the integral expression should be 1 over, in this case, b minus a would be 8 minus 0 times the integral from 0 to 8 of t of x dx. And in order to find out what those values are, I'm going to go ahead and graph this table here. So at 0, I've got 100. At 1, I've got 93. At 5, I've got 70. At 6, I've got 62. And at 8, I've got 55. And I'm going to go and just draw trapezoids down because I'm going to be using a trapezoidal sum. That's my third trapezoid, and this should be my fourth trapezoid. Notice how they conveniently told me to do 4 subintervals. So this is going to be 1/2 times the first base is going to be here. So it's going to be 1, or rather, I'm sorry, that times the height, not the base. The first base is going to be 100 minus 93, or rather plus base 1 plus base 2 for area of a trapezoid. Plus the next one's going to be 1/2, the height's going to be 4. Base 1 plus base 2 is going to be 93 plus 70, plus 1/2. The next base is going to be 1 from 5 to 6, 70 plus 62. And then plus 1/2, the last base is going to be 2. And if I scroll a little bit to the right, base 1 plus base 2 is going to be 62 plus 55. Now again, in this case, the AP exam this year is non-calculated. Even if it was calculated, I would encourage you not to simplify your answer, just to help yourself move a little bit faster. But the one thing you definitely don't want to forget is you don't want to forget carrying over the 1/8 that was there for average value. So please make sure that we are bringing that over. And since it says indicate units of measure, that would be in degrees Celsius. If you wanted an answer, you could go and just punch it into the calculator if you wanted to. You could say that after adding all this stuff up, you end up getting 75.6875. And I should get rid of that equal sign there. Okay, I'm going to go and clean up the board a little bit. Copy this down if you need to, hit the pause button if you need to, and I'll be back with parts C and D. And we are back, taking care of part C after cleaning up the board here. It says find the integral from 0 to 8 of t prime of x and indicate units of measure. Okay, we can do that. So from 0 to 8, t prime of x dx. Well, that's going to be t of 8 minus t of 0. So for that, we're going to go to the table. T of 8 is 55. T of 0 is 100. So that ends up becoming negative 45 degrees Celsius. And it says explain the meaning of the integral from 0 to 8 of t prime of x dx in terms of the temperature of the wire. So I'm going to go into the typing function here so that I can make sure the writing is clear. So what I'm going to say is I'm going to say the temperature of the wire changed by negative 45 degrees Celsius on the time, oh, not on the time, what am I saying? On the interval 0 to 8 centimeters. And I think that's a pretty good interpretation right there. All right, let's take a look at D. It says, are the data in the table consistent with the assertion that t double prime of x is greater than 0 for every x in the intervals 0 to 8? Explain your answer. Okay, let's take a look at this problem here. Now, part D was really confusing for a lot of people, especially the people who were taking this in 2005. They weren't really sure where this problem was going. But remember, they're asking about t double prime of 0. And so it makes sense we should probably find some information about t prime of 0. So here's what I'm going to do. I'm going to pick certain intervals on this table, and I'm going to go and just find out what t prime approximately is. And the way I'm going to do that is I'm going to go and just select values. So I'll go ahead and just come up here. Let's find out what the change in temperature was from 0 to 1. So from 0 to 1, so t of 1 minus t of 0 over 1 minus 0. Well, that ends up becoming 93 minus 100 over 1 minus 0, which is negative 7. I'm going to keep him for a second here. I might need him later. And then what I'll do is I'll go back up to the table. I'll do from 6 to 8. I'll do from 6 to 8. Now, there's a reason why I'm choosing these values here. T of 8 minus t of 6 over 8 minus 6. Well, that's going to be a 2 up here. And let's see here. What are those numbers here? 55 minus 62, so negative 7. Okay. So from here, let's go and just choose another set of numbers here, just in case. What I'm going to do is I'm going to go and say, all right, well, what is... let's do the difference between the 5 and the 6. So t of 6 minus t of 5. T of 6 minus t of 5 over 6 minus 5. Well, that ends up becoming 62 minus 70 over 1, which is negative 8. Now, this is what I want here. Now, if you saw what I'm doing, I'm just kind of finding rates of change for t prime, or rather rates of change for t, in other words, t prime. And what I wanted was something that was this, and then something that was this. In other words, a number, and then a number smaller than that. Now, I actually double scored because I found a number smaller than both at the same time. The reason why this is important is because what this tells me is that the rate of change, right? Remember, this is t prime of x somewhere on 8 to 6, right? This is t prime of x somewhere else. And what I can say is I can say that t prime of x, based on this information here, or even based on this information here, I can say that t prime of x decreases because the number actually gets smaller from one point to the next. And if t prime of x decreases, that means that t double prime of x has to be less than 0 on 0 to 8. And the theorem that allows me to say that, and it's not, we usually think about this theorem in a very specific kind of way. We think about it in terms of finding exact values. But in this case, the theorem they want us to use is we want to use mean value theorem. So we can say, therefore, by MVT, and we want to say, because t of x is twice differentiable on 0 to 8, we can say that t prime of x decreases somewhere on 0 to 8, and therefore t double prime of x must be less than 0 somewhere on 0 to 8. So the answer ultimately is no. the assertion is incorrect. And I think that should do it for this wire FRQ. Hopefully that makes a little bit of sense. If you have any questions, as always, please leave them in the comments section, and I will see you in the next video.